Today's lesson is on section 11.5, apply the distance and midpoint formula, but actually we're not going to worry about the midpoint formula. We're just going to worry about the distance formula because that one's actually going to be something we'll see on the MCA and something that we should know for 8th grade. What you're going to realize, though, this is also in chapter 11. The distance formula is really just like the Pythagorean theorem. So today I'm going to kind of convince you of that and show you how I can find the distance between 2 points just by finding, again, that hypotenuse of a right triangle. That's pretty much what it'll come down to. But I'll try to show you how that works on the next few pages. First, I'm going to start off with a little example problem that'll help us realize how the distance formula works. And it says here, how do you find the distance between 2 places? And what I've picked is a few cities that are nearby Plainview here. And some nice little illustrations to go along with it. I'm kind of estimating, I'm not really sure the exact numbers, but I'm guessing that Plainview to Lewiston, I estimated at about 26 miles. I know that may not be right. You don't have to call me up and tell me that it's not 26. I'm just kind of guessing. Let's say along one route it's 26 miles. So let's say I know that distance. And then let's say I know the distance from Plainview to Winona. We'll say that's about 51 miles, somewhere along the same route. Well, if I know that Plainview is 26 miles from Lewiston, and Plainview is 51 miles from Winona, there's a way to figure out then how far Winona and Lewiston are apart. I can figure out the distance between those 2 cities. How would I do that? I usually pose this question to students, and then after they think for about a minute or two, they might realize, well, if I know this distance here is 26, and I know along that same line then from Plainview to Winona be about 26, let's say it's about right here, they just need to be able to figure out what this distance is. And how can you do that? Well, it's just kind of by cutting that distance out. Or in terms of using the numbers, it'd be like subtracting. If I take 51 minus 26, that'll tell me what's left over, which should be this distance right here between Winona and Lewiston. So if you have some kind of point of reference, like in this case Plainview, and you know how far apart 2 cities are from Plainview. I know that they're 51 miles apart and 26 miles apart, or away from Plainview, the point of reference. By subtracting those, you can figure out how far apart those 2 cities are from each other. And in this case, again, I get about 25, but that's just kind of an estimate, again. So don't feel like you have to correct me on that. I'm just kind of making up a problem and taking a guess just to show students, well, how I can do it is subtracting the distances of those 2 places if I know how far apart they are from, or how far they are from the point of reference. Well, let's use that same idea now on a grid. And again, this is how I could find the distance between 2 points. Or even if it was like a real world problem, if I had the points again on a grid and I knew the distances from the origin, I could do the same kind of thing. But we'll just do it for a basic problem like here on the grid. Let's say the origin is kind of our point of reference in this case. Let's say that's Plainview. This point 23 is Lewiston, and this point 87, that's Winona. Now in this case, I know that the points are so many units in each the horizontal and vertical direction away from Plainview, but I know each of those coordinates. Like if I look along the x-axis, I know that Lewiston is, well, it looks like it's 2 coordinates away on the x-axis, because that's the x-coordinate for it. And I know that Winona is 8 coordinates away. So just in the horizontal direction, I can figure out how far apart Lewiston and Winona are by, like we did in the previous page, subtracting 8 minus 2. Because I know that Winona is 8 units away from me, Lewiston is 2 units away from me. So if I subtract those, that should tell me how many units horizontally they're away from each other. I could even show this on the graph by kind of showing a line here that says, well, here's Lewiston, I'm on Lewiston. And I go 1, 2, 3, 4, 5, 6 units over. Yeah, what do you know? It's 6 units horizontally between Lewiston and Winona. I could do the same thing vertically. Here's Plainview. It looks like if I go up 3 units, I'd be level with Lewiston. And if I go up 7 total, I'd be level with Winona. Well, you know, those are the 2 coordinates they have, 7 and 3. And so if I took 7 minus 3, I could figure out how many units vertically they're away from each other. So, and 7 minus 3 gives me 4. Showing this on the grid as well. Vertically, they're 4 units apart. That'd be like going from here and saying 1, 2, 3, 4. So what do you know? It's 4 units up. Well, look at what we've done now by drawing those 2 lines in that show how much vertical and horizontal distance there is between the 2 cities themselves. If it's 6 over and 4 up, almost kind of like finding the slope. Realize it's almost kind of like that. It's like how far do you go over and up? Those are like two legs of a right triangle. And then, what do you know, I'm trying to find like this distance right here. The problem's asking me how far apart are Lewiston and Winona. Well, it's like finding that straight line distance, which is like your C, like your hypotenuse. By drawing the lines 6 and 4, and I've made kind of a right triangle, and I'm just trying to find that C. So I'll ask students now, what do you think, or how do you think you could find out what C is? Well, realize, and I want students to realize this is kind of like using the Pythagorean theorem. A squared plus B squared equals C squared. A squared is going to be, in this case, it'd be like 4. B squared could be C, or 6, I mean. B squared could be 6. And then that C is the distance between the two cities, which is what I'm trying to find. So what do you know? It's just like using this formula like we did a couple lessons ago. 4 squared gives me 16. 6 squared gives me 36. That equals C squared. 16 plus 36 gives me 52. And so I'd have to take the square root of 52. But again, this is something students should hopefully be able to kind of estimate in their head as well. They know that the square root of 49 is 7. So the square root of 52, well, that should be something maybe a little bit above 7, like 7.2. I think if I punch in the calculator, I get about 7.2. So that will be the distance between Lewiston and Winona on this grid, or for example. The distance formula, they have it in the book. And I would like you to put it in your notes. But what I'm trying to explain to you here, even just on this page, is that I think the distance formula is more complicated than it looks. All it's telling you to do is do exactly what I did up there, make a right triangle. By subtracting the coordinates, you find your A and B, and then it's just like finding the hypotenuse, finding the C, just like we've done. Here is the distance formula. It says D equals with the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, it looks kind of confusing, but realize it is just the Pythagorean theorem. Here's the Pythagorean theorem. We'll realize that just like we did this problem above, at the end here, I have to take the square root of both sides to be able to find out what that distance is. So if I just do that right away, what I get is that C, that hypotenuse, it ends up being, yeah, the square root of whatever A squared is and B added to B squared. Well, then if I look at it like that, here's the big square root. In this problem, here's the big square root. Here's each of those numbers squared. Here's each of those numbers squared. Here's adding them together. Here's adding them together. So look, it is really the same thing. The only thing that looks different is right here I have A and B, and here they have the x2 minus x1. Well, where does that come from? That just comes from what we did up here when we subtracted the coordinates. That's how I found out what A and B are. So just realize that the Pythagorean theorem and the distance formula, they're really the same thing. The distance formula is just broken down more so that you could use it with 2 points, x and y coordinates. But realize that all you do is you subtract the coordinates. That tells you these two sides, like 6 and 4, and those make the legs of your right triangle. Once you've got those two, now if I have a picture, it kind of helps too. I'm just trying to find out what C is, just like we did a couple lessons ago. So just going through a couple examples, here's what it might look like. And I want students to graph these when we're doing them, because on the MCA I'll give them graph paper to use, so they could even graph out a problem like this and see it visually. But even if you can just do it with the subtraction, that's great too. I just want them to see, though, what's really happening. It says find the distance between these 2 points, -6, -1, and -1/8. So what I'm really doing, kind of like we did in the previous problem, it's like I'm going to subtract the coordinates, almost kind of like finding the slope, because you're finding out how much you go over and how much you go up. So I'm going to do like 8 minus, and remember it's subtraction, so 8 minus -1, I'm going to have to chop. I'm getting 9 here when I subtract the y coordinates. If I take -6 minus -1, I'm going to get -5. And I'll show you how that works kind of here on the grid. Just realize, when we're talking about distances, we usually don't talk about a negative distance. Like we don't talk about I go -5 miles to work today. So even though I got a negative number there, that's okay. You could still think of it like a positive, and it'll still work out nice. So I'll show you what this is like. So again, I found out 9 here when I subtracted the y coordinates. Well, that's like saying between these 2 points, what do you know? There's 9 units between those 2 points vertically. The way I subtracted them, I got -5, but again, you can just think of 5. It's the same thing when you're talking about distance. Well, that means that I got 5 units horizontally between these 2 points. look what I've made now. I've made two sides there of my triangle. And if I just figure out that, well, here's what I'm trying to find is really that distance, right? Now I've made a right triangle, and I'm just trying to find out what C is. So I can plug these into the formula. A squared plus B squared equals C squared. 9 squared plus 5 squared equals C squared is what I'm going to find out. C squared, again, that's going to be like my distance between the 2 points. 9 squared gives me 81. 5 squared gives me 25. If I add those together, I get, 106. And again, right now, hopefully students can make an estimate in their head. The square root of 100 is 10. So they should be able to guess, well, then, okay, this should be about 10 point something, whatever that may be. Square root of 106 is 10.3. So C equals 10.3. We talked about in the previous lesson how when you're finding the hypotenuse of a right triangle, it should be bigger than the two legs, because obviously it's the longest side in the triangle. So that makes sense. If this is 10.3, yeah, it's bigger than 5 and 9. So yeah, that kind of makes sense along with what we're figuring out too. So we can still double check and make sure our answer makes sense in terms of the problem. One more example, and this could be exactly what a student might see on the MCA when we take that very soon. So just showing, even if I don't have a grid, I can still do it. But again, like I talked about, I'm going to give students graph paper when you guys are taking the MCA, so just realize you'll have that accessible to you. But here's how you can do it even without the graph. So find the distance between the 2 points. Well, like we talked about, it's really like if I want to find the horizontal or the vertical distance between them, I'm just going to subtract the two y coordinates. 9 minus -3, so chop chop. That's like saying they're going to be 12. These points should be 12 units apart vertically. If I subtract 4 minus -1, chop chop, I'm going to get 5. What I'm really finding out is that these 2 points are 12 apart vertically and 5 apart horizontally, whatever it may look like on the grid. And let's say these are the 2 points. Again, I didn't really draw a grid, but here's just a little picture to help visualize this. I'm finding this distance. So what do you know? It's like making a right triangle. And I'm going to try to find out what C is. 5 squared plus 12 squared equals C squared. There's the Pythagorean theorem. Just plugged in my two sides. 5 squared is 25. 12 squared is 144. That equals C squared. Add 25 and 144 together, I get 169. Square root of 169 actually is a perfect number. It's 13. So the distance between those 2 points must be 13. So today's lesson may look a little new with the distance formula, but really, or it may sound like something new, but really it just goes back to the Pythagorean theorem. Finding the distance between 2 points is just like finding the hypotenuse of a right triangle.